Okay, we looked at drawing structures from formulas. And what I've got here is I've got 5 different structures that make 5 different shapes. And that shape is determined by the number of bonding pairs and non-bonding pairs. It has everything to do with the electrons. So if I look at all the electrons here, they're all around the center atom. They're all bonding with something else. So I have 4 bonding pairs. And I have none that are non-bonding. I've got 4 bonding pairs and no non-bonding pairs. I get a tetrahedral shape. So tetra means 4, which means I've got 4 things attached to it. And it makes kind of like a little pyramid. Can you see that? So this is a tetrahedron, and this is the most common type of bond that carbon will make, because it can bond with 4 things, and it wants to spread them all out. You see, all the electrons on the outside of these hydrogens are all negative, and they're pushing each other away. And so what they do is they're all equally spaced apart from each other. See? So no matter which side you look at, it really looks like the same triangle because they're all evenly distributed in space. The second type, we have 1, 2, 3 bonding pairs of electrons. But notice there's one out here that's not bonding with something else, and so we call that a non-bonding pair. Now, remember, these electrons are taking up space, kind of up in here. So you can kind of imagine it's a lot like a tetrahedron, but we just pull one of them off. So the electrons up here are taking up space and pushing these hydrogens down. Not quite as severely as they are in a tetrahedron, but just a little bit. And this makes a little pyramid. And so we call it a trigonal. Let's try trigonal pyramid. Trigonal means it makes a triangle, no matter which way you look at it. From the side, it makes a pyramid. Next one, water, H2O, one of the most important ones. And we have 2 bonding pairs and 2 non-bonding pairs. So those non-bonding pairs take up room. So they're spread out up here in this sort of cloud, and they push these 2 hydrogens downward to make this water molecule bent. So we call it a bent shape. Third one. Here we have bonding pairs. And we're only concerned about the bonding pairs and the non-bonding pairs around the central atom. So here I have 3 bonding pairs and no non-bonding pairs. And what that gives me is a trigonal, planar molecule. Because there are no electrons up here to push these down, what happens is these guys all push themselves away to be flat. And I put springs in there to make it go flat. Otherwise, it would look just like this one. But this guy, because there are no non-bonding electrons to take up space like there are here, this one goes flat. So we call it trigonal planar. Trigonal means it makes a triangle, and planar means that it's flat. All the molecules are in the same plane. Then there's one more. If you look at this central atom here, the carbon, it has 2 bonding pairs. Even though it's a double bond there, there's really only 2 bonding sides. And there are no non-bonding pairs. So because there are no those non-bonding pairs to bend the molecule, like we did with water, remember these 2 non-bonding pairs push those 2 hydrogens down to make it bent, we've got a straight molecule. Everything's in a line because there aren't any electrons up here to bend these guys. So we call this linear. So, linear, trigonoplanar, bent, trigonal pyramid, and tetrahedron. So, those are 5 shapes of molecules that you ought to know. Tetrahedral, trigonal pyramid, bent, trigonal planar, and linear.